Good morning, students. Today we are going to study about communication theory. This is our GATE training class. Already you studied this subject, communication theory. Today we are going to discuss about communication and the modulation techniques, then overview of communication, important formulas and important concepts of communication theory. Then we will do some problems. Okay. First introduction. So we all know about communication. What is communication? So communication is nothing but we are transferring information from one place to another place. That is called communication. So we are conveying information or transferring information from one point to another point or one place to another place. Okay, ma. So from between two devices or between two systems or between two human beings or from one human being to one system or one bird to one system, whatever may be that, the information exchange is called as communication. So here we have elements of communication. So these are all the basic blocks of communication. First one is information source, second one is the transmitter, third one is channel, receiver, destination and noise. These are the important blocks of communication system. Information source means the actual person, the actual device which generates the information is called information source. Next one is a transmitter. The transmitter converts the information into suitable form. So it is only responsible for transmitting the signal. So the next one is a channel. So different types of channels are available. We know very well. Wired channel, wireless channel. So many channels are available. In wired channel, coaxial cable, twisted pair cable, optical fiber cable, different cables are also available. So based on the type of channel, so the transmitter will do conversion. So the transmitter will change the original information into the suitable form, because the original informations, most of the original informations are natural informations. Most of the informations are natural informations. So some informations are electrical, some informations are non-electrical. So those informations should be converted into suitable form to transmit through the channel. So based on the type of the channel, the transmitter will do the function. Next, the receiver. At receiver side, we are doing the reverse process of transmitter. So the receiver will receive the information. From the received information, from the received signal, it will recover the original information. Then it will transmit the original information to the destination. So what's happening in channel? So during transmission through the channel, noises are added. Some unwanted signals are added in the channel. So that noises are there. Okay, so the noises are there. So noises are added at this, some unwanted signals are added. Signal reduction is also happening there. The signal reduction, signal strength reduction is called as loss. So the receiver's responsibility is to receive the weak signal. From the received weak signal, it has to recover, it has to get back the original information. Then the receiver will transmit the original information to the destination. So these are the elements of communication system, the information source. So the information source or any type, so group of words, code, data symbols or signals, man-made voice. Now today I am taking class. So my voice is an example of signal. I am the transmitter. I am taking class. I am giving lecture. So my lecture is an example of signal. I am speaking here. So this voice signal is converted into electrical signal. Then electrical signal is transmitted through set of transmission channels, not a single transmission channel. It is a combination of channels, because nowadays we have connected in online mode. So all are communicating by using electronic gadgets, systems or laptops or mobile phones. Through the devices only we have connected together. So the information is transmitted in electrical form. So it is transmitted through set of communication channels. Up to certain range it is transmitted through electrical cable, then through ALS channel, then from that receiving point to the local system, it is again through cables. So the transmitter is the same thing. So it is used to convert the original signal into suitable form. Next, a channel. So channel is a physical medium. So okay, the different types of channel mediums. For each and every channel, we have some types of losses. We have some disturbances. We have some problems. So after selecting the channel, we have to consider the problems associated with the channel. Okay, next one is a receiver. Receiver blocks removes the noise first because the received signal is a noisy signal. So the receiver receives the noisy signal. From the noisy signal, it removes the noise. Next, it identifies the original information. From the original information, it will get back the original signal. So it will convert the received signal into suitable form, original form. Then the original form signal is delivered to the destination. Next, signal messages are informations. We know very well. Here, the signal is nothing but a physical quantity which varies with respect to time or space or independent or dependent variable. So, his signal is nothing but is a representation of the real-time data. For example, we are collecting so many real-time data. For example, take one example, the room temperature. Okay, so the temperature of one particular room or the temperature of one boiler or heartbeat of one particular patient, when we monitor that particular parameter over a certain period, over a single day or over a week, so we can draw the graph by we can use the graph to represent the data from morning 8 o'clock to evening 6 o'clock. What are the values? So we can use some signal to represent the variation in the parameter. So signal is nothing but it is a representation of real-time data with respect to certain parameters, some independent or dependent parameter. So the parameter may be time, space, or frequency, whatever may be that. With respect to that, what is the variation in the parameter? So here in for mathematical analysis, we are using some signals. Okay, so the general signal is represented like this. For example, m of t equal to a cos omega t plus phi. Why? Because for signal, for each and every signal, three important parameters are available. One is amplitude, second one is the frequency, third one is phase. Okay, ma. So by using these three parameters only, we can represent any signal. Okay, ma. So the amplitude is important. So amplitude means the height or energy. Next one is the frequency. Third one is phase. So each and every signal is represented by using these three parameters. Okay, ma. So A is the amplitude, omega is the frequency, phi is the phase in radians. Okay. So different types of signals are available. One is analog signal, second is a digital signal. So analog means continuous. The amplitude of the signal is continuously varying with respect to time or any dependent parameter. If it varies continuously, that signal is called as analog signal. Next, digital signal. Next, in between these two, we have one more category, that is discrete. So the discrete means the values are continuous, but we are taking the values at certain time instance. That is called discrete. But digital is not like that. In digital, we have only two alphabets. One is 1, another one is 0. That is called digital. In analog and digital, two classifications of signals. Okay, ma'am. This is a signal, digital signal. So next we have two signals. One is a baseband signal, another one is a band pass signal. So the baseband signals mean the signal contains zero frequency or near to zero frequency. That means the original signals are called as baseband signals. After modulation, the signals are called as band pass signals because the original signals are available in its own frequency range. So that is called base band. So each and every signal is having its own base frequency band. So the original signal is called as baseband signal. But here for communication purpose, we are doing modulation. During modulation, we are changing the signal. That signal is called as band pass signal. So next, the important in communication system, the important thing is modulation. So the modulation means first before studying the modulation, we have to know the reason why we are doing modulation. That is important because all the natural signals or all the original signals are low frequency signals. So the low frequency for short range communication or for short distance communication, the low frequency signals are suitable. But for long distance communication, the low frequency signals are not suitable. So we are doing modulation here. Okay, ma. So see the definition already we know very well. This definition, it is the process of varying the characteristics of high frequency carrier in accordance with the instantaneous values of modulating or message signal. Okay, ma. So the low frequency message signal is available. So the low frequency signal message signal is not able to travel long distance. So we are using high frequency carrier signal. The carrier signal is named as carrier because it is used to carry the information from one point to another point. So it is called as carrier signal. The carrier signal's frequency is very high. So we are selecting one particular high frequency signal as carrier. Next, we are doing modulation. In modulation, we are changing the characteristics of the signal. In analog signal, three basic characteristics are there. One is amplitude, second one is frequency, third one is phase. So here in modulation, we are changing any one of those three characteristics, not all the three characteristics, any one of those three characteristics with respect to time. So the remaining two characteristics are not changing. The remaining two characteristics are maintained as constant. So this is called modulation. So the modulation is done at transmitter side. The reverse of modulation is called as a demodulation because the original signal is modulated into modulated signal. Okay, ma. But at receiver side, what we are expecting? We are expecting the original signal, not the modulated signal. The receiver or the destination device is expecting the original signal which was transmitted by the transmitter. So, but in transmitter, the original signal is modulated. It is converted into high frequency. So at receiver side, we have to do the reverse function. So at receiver side, we are doing the reverse of the modulation, that is called as demodulation. In demodulation process, the signal is recovered back. Okay, ma. Next one is the types of modulations. So different types of modulations are there. So first one is continuous wave modulation and pulse modulation. In this class, we are going to study about continuous wave modulations only. Okay, ma. So continuous wave modulation means the analog signal modulation. Here the signal is called the analog carrier signal is used. So this modulation is called as continuous wave modulation. Here, see here, two important parameters. One is amplitude, second one is angle. So the angle means the frequency and the phase are combinedly called as angle. Okay, ma. So we are changing either amplitude of the signal or frequency of the signal or phase of the signal. So these two techniques are combinedly called as angle modulation. The first one is called as amplitude modulation. In today's class, we are going to discuss about this amplitude modulation in detail. Okay, ma. Any doubt up to this? These are all the basic concepts of communication. So communication block diagram is there. In block diagram, different devices are there. Transmit, original source, transmitter, channel, receiver, detector, destination device. Next, frequency, different signals are available. Analog signals, digital signals are available. Okay, ma. Any doubt, ma? Okay. Next one is, this is, next we are going to see the types of modulations. Okay, different types of different parameters are there. Based on the parameters, different types of modulations are there. First one is amplitude modulation. In amplitude modulation, the amplitude of the carrier is varied. Okay, ma. But in frequency modulation, the frequency of the carrier signal is changed. In phase modulation, the phase of the carrier is changed. But in these three modulations, only that particular parameter is changed with respect to message signal. The remaining two parameters are not changed. Okay. So why? What is the reason? Why we are using modulation? So benefits of modulation. The first thing is to reduce the length of or height of the antenna, because the antenna size is inversely proportional to frequency. Okay. Okay, ma. So to reduce the antenna height, we are choosing high frequency signal. Next one is for multiplexing. Multiplexing means simultaneous transmission of multiple signals. Okay, ma. So direct transmission of multiple signals is not possible because for each and every signal, we have to design the complete communication system, but it is not possible there. But here, by use of modulation, by using single communication system, we can transmit different frequency signals, different types of information signals. So that is called multiplexing. Next, to reduce noise effect. Next, to avoid the equipment limitation or to reduce the size of the equipment. Equipment limitation is there. Okay, ma. So for each and every frequency, okay, if you are using without modulation, if you are transmitting without modulation, means for each and every frequency, one set of equipments needed. Okay, but with the help of modulation, the number of equipments is reduced. Okay, first one is amplitude modulation. What is called amplitude modulation? The amplitude of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. So in this diagram, we have two signals. The first signal is low frequency message signal. The second signal is high frequency carrier signal. See here, the high frequency carrier signal is having one constant amplitude. That amplitude value is AC. The message signal amplitude is AM. That is represented in the diagram itself. Okay. This high frequency carrier signal's amplitude is constant. Before modulation, the carrier signal is having constant amplitude value, AC. But after modulation, this amplitude value is going to be varied with respect to message signal. That modulation is called as amplitude modulation. See here, this is our diagram. See here, the inner waveform is our carrier waveform. But here, the carrier waveform is present, but the amplitude is not constant. The amplitude is varying with respect to the message signal. So the message signal is available in envelope of this modulated signal. This is our modulated signal. In the modulated signal, this is maximum amplitude. So we have envelope so maximum amplitude here. Next one is minimum amplitude here. Okay so the maximum amplitude is equal to AC plus AM. What is AC plus AM? AC is the amplitude of the carrier and AM is the amplitude of the message signal. So the maximum amplitude is equal to addition of two amplitudes. Okay, message and the carrier. Next, minimum amplitude value is equal to AC minus AM. So the carrier amplitude minus message signals amplitude. Okay Next, we are going to see about the mathematical representation, equation representation of amplitude modulation concept. So here the area carrier signal is represented by using one equation. So each and every signal is represented by using three parameters. Okay amplitude, frequency and phase. Here we are considering only two parameters, amplitude and frequency. So this is our carrier signal. AC is the amplitude of the carrier signal and omega C is the angular frequency of the carrier signal. Okay. Next, modulating signal, baseband signal or message signal. The message signal is called as modulating or baseband. Okay because it is used to modulate the carrier, so it is called as modulating signal. Second term is baseband signal because it is in its base frequency. So this is baseband signal. That is equal to AM. The suffix M represents modulating. Okay, here the suffix C represents, it is carrier. C represents carrier, M represents modulating or message signal. So the AM is the amplitude of the message signal. Omega M is the frequency of the message signal. Okay, ma. This is our equation. So the amplitude modulation, after modulation, the standard equation is this one. Okay, ma. S of t, the modulated signal equal to AC cos 2 pi fct into 1 plus m of t into cos 2 pi fmt. This is the final expression. Actually, this is the gate training class, ma. Here I am not taking the complete expression. Here we are going to discuss about the complete chapters, amplitude modulation, analog modulation concepts. All the concepts we are going to revise. Okay, just here in this class, we are revising the concepts. What are the concepts available? What are the equations are available? Diagrams are available, and modulation methods and demodulation methods are available. Formulas, just okay, ma. So this is the modulated equation, the final equation of amplitude modulation. AC cos 2 pi fct into 1 plus MA cos 2 pi fmt. Okay, already you studied in 4th semester of your syllabus. Okay, curriculum. Okay, ma. Here, this term is important. The MA, the modulation index is important. Here in modulation, this modulation index. So the modulation index value is equal to AM divided by AC. AM is amplitude of message signal. AC is the amplitude of carrier signal. So this modulation index is important parameter. The time domain representation of AM. Just we are expanding this equation. This S of t, we are expanding this one. After expanding this equation, we got these three terms. The first term, AC cos 2 pi fct plus mu or m, any letter we can use. The modulation index is represented by using the terms m or mu. Okay, both the letters we can use. So mu into AC by 2 cos 2 pi fct plus 2 pi fmt plus mu AC by 2 cos 2 pi fc minus 2 pi fmt. So after modulation, the modulated signal is there. So after expanding on the simplifying the equation, finally we got this equation. This equation is our amplitude modulated signals equation. The first term, see here, then first term we have amplitude AC, the frequency is FC. Only one frequency term is available. That frequency is the frequency of carrier signal. So this first term is called as carrier signal with pure carrier signal without modulation. Okay, ma, first term. The second term, see the second term. In second term, we have mu. Mu means what? Modulation index. In modulation index, we have this term AM. So in second term, we have AM. That means the amplitude of the message signal is involved. It is included in the second term. Next, see the frequency. The frequency is equal to Fc plus Fm. So Fc is the carrier frequency, Fm is the message frequency. So the message frequency is also included. Okay, ma. So the third term is the minus 2 pi Fc minus 2 pi Fmt. Here the frequency is Fc minus Fm. Here in third term also both the parameters are involved. Amplitude of carrier and amplitude of message. Frequency of carrier and frequency of message. So all the terms are involved in second and third terms. So in amplitude modulated signal, we have three terms. Okay, first term, second term, and third term. Pure carrier term and one plus term, Fc plus Fm term, and another term is Fc minus Fm term. Okay, next one is the frequency domain representation. So in the frequency domain representation, we have three frequency components. One is see the frequency previous equation. In this equation itself, we can understand. So one frequency component is Fc. The another frequency is Fc plus Fm. The third frequency is Fc minus Fm. So here we are drawing the diagram. This is the diagrammatic representation of that. Here center Fc term is there. Next is both the sides. Okay, Fc term is there. Next Fc plus Fm term is there. Fc minus Fm term is there. So here we have two terms, three frequency terms, Fc, Fc plus Fm, Fc minus Fm. Next, modulation index representation. So the modulation index formula already we know very well, AM divided by AC, but another formula is there, A max minus A minimum divided by A max plus A minimum. Okay, if they give carrier signal and modulating signal separately, means you have to use this formula to calculate modulation index value. But if they give modulated signal diagram, means from the diagram we have to calculate maximum amplitude of the envelope and minimum amplitude of the envelope. From the maximum amplitude and minimum amplitude, we can calculate the modulation index value by using this formula. So two different formulas are available to calculate modulation index value. So based on the given parameters, we can use the suitable formula. Okay. Next, percentage of modulation is there. Just it is a simple one. Just a multiplication of this modulation index value by 100 gives percentage of modulation. Okay, ma. So this value into 100 is equal to percentage of modulation. So based on this modulation index, we are categorizing the modulation into three. One is under modulation, critical modulation, third one is over modulation. So these three modulation techniques are called as degrees of modulations. Okay, my 3 degrees of modulation, 3 categories of modulation based on modulation index value, all are same. So the modulation index plays an important role. So first one is under modulation. If the modulation index value is less than 1, that is called under modulation. If the modulation index is equal to 1, that is critical modulation. If the modulation index is greater than 1, that is called over modulation. So what it represents? The modulation index is less than 1 means what? The amplitude of the message signal is less than amplitude of the carrier signal. The modulation index is equal to 1 means what? The amplitude of the message signal is equal to amplitude of the carrier signal. Over modulation means the amplitude of the message signal is greater than the amplitude of the carrier signal. That is the meaning of the modulation index value. So next 3 diagrams represents the degrees of modulation. The first diagram is the critical modulation, MA equal to 1. This is critical modulation. Okay, this is the first one. Here the EM equal to EC. Both are same. The amplitude values of carrier and message are same. This is the diagram of critical modulation. Next one is under modulation. Under modulation, MA less 1. The second diagram is the diagram of under modulation. Okay, ma. Next one is the third modulation. Over modulation. The over modulation, the third diagram is the over modulation. See here, when we choose over modulation, here some amplitude clipping is there. Okay, some portions, the negative portions, the envelope portion is missing here. This is the problem what we are facing with over modulation. This is the spectrum of the amplitude modulation concept. So time domain representation is over, frequency domain representation is also over, modulation index is over, percentage modulation is over, formulas over. Next, based on the modulation index, we have 3 degrees of modulation, 3 classifications of modulation. All the 3 classifications are also over. Okay, is it clear to you? Any doubt up to this? Okay, ma. Next, we can see the bandwidth. This is the diagrammatic representation of amplitude modulated signal. Here we have 3 frequency component. One is Fc, second one is Fc plus Fm, third one is Fc minus Fm. This Fc is a center frequency. Okay, here in amplitude modulated signal, we have three components. First component is Fc component. It is placed in center. Next component is Fc plus Fm. This value is greater than Fc. So this component is called as upper sideband component because of greater value. Next, third term is Fc minus Fm. This Fc minus Fm value is less than Fc. So this is lower than Fc. So it is called as lower sideband. So two sidebands are there. Next, the amplitude of value of the terms. For Fc, the amplitude value is Ec. For upper sideband and lower sideband, the amplitude value is MEC by 2. The modulation index into carrier amplitude divided by 2. That's all. This is a diagrammatic representation. Okay, ma. So in problems, they will ask to draw the frequency spectrum of amplitude modulated signal. Next one is bandwidth. So bandwidth means the frequency range. Upper frequency range minus the lower frequency value. Here in amplitude modulated signal, AM signal, we have three frequencies. Fc, Fc plus Fm, Fc minus Fm. Which one is greater? This one is greater. This one is the upper one. Okay, ma, Fc plus Fm. Which one is the lower value? Fc minus Fm value. Take the difference of these two terms, Fc plus Fm minus Fc minus Fm. Just substitute this one. After substituting and simplifying, what we are getting? The bandwidth is equal to 2Fm. So the bandwidth requirement is a problem with here because the bandwidth is equal to 2 times of the frequency of the modulating signal. Okay, so the modulating signal's frequency is Fm. Omega m angular frequency, Fm is a normal frequency. Okay, if you transmit the modulating signal directly without modulation, the frequency requirement is only Fm. So the Fm frequency is enough to transmit the signal directly. But here we are using modulation concept. After modulation, to transmit the modulated signal, the bandwidth requirement is increased. Okay, ma. Instead of Fm, here 2 Fm is required. So the bandwidth requirement is increased here. Next, you can solve one problem. Okay, I'll have to take this problem, solve this problem and check the answer. Okay. First one is calculate the modulation index and percentage modulation. If instantaneous voltage of modulating signal and carrier signal are 40 sin omega t and 50 sin omega ct respectively. Okay, so we have to calculate modulation index value and the percentage modulation value. Okay, what are the values given? Given parameters, the modulating signal is given 40 sin omega mt. This is our modulating signal. Next, carrier signal is also given 50 sin omega ct. From the given problem, write the values. Okay, so the EM amplitude value of modulating signal is 40, amplitude of carrier signal is 50. Just write the values. Okay, next write the formula. Modulation index formula is M equal to EM by EC. Directly substitute the values 40 divided by 50 equal to 0.8. So the modulation index is calculated. That's all. All of you check your answer, ma. Next, percentage modulation. This percentage modulation is equal to M into 100. So 0.8 into 100 is equal to 80%. So the percentage modulation and modulation index is over. Okay. Okay, modulation index and percentage modulation calculation is over. Our next topic is amplitude AM power distribution. Okay, ma. So the total power is distributed. So for each and every signal, one power requirement is there. So bandwidth requirement is there. Like that, power requirement is also there. Okay, ma. So we have to provide that much power. So that the signal is requiring that much power. Okay, ma. So the bandwidth is increased as 2 FM. But here we are going to discuss about the power variation. Okay, here AM signal is having three components: unmodulated carrier, lower sideband, and upper sideband. Three components are there. So the total power of the AM signal is equal to three components are there. No, so the total power is equal to addition of power of all the three components. First, power of carrier component plus power of upper sideband plus power of lower sideband. So all the powers, individual powers are added together. That gives total power. Okay, ma. So the power formula is available. Just to note the final formula. This is equal to E square by R. That we know very well because the power formula equal to I square R or E square divided by R. This is the basic formula. Here we are using the RMS value. For each and every term, we are substituting the corresponding voltage value. After substituting the voltage value, finally we got the equation. The power of carrier is equal to EC square divided by 2R. The power of upper and lower sideband is equal to ESB square divided by R. This is our final equation. Okay, Dhamma. So the problems in GATE class, in most of the GATE question papers, they will ask the problem. Okay, ma. They'll ask the problem or they will ask some comparison questions like that. Explanation. So the total power depends on how many parameters like that they will ask. Otherwise, they will ask to solve some problems. So the total power, the final equation of this total power. The total power is equal to carrier power into 1 plus m square divided by 2. M is the modulation index. P is our carrier power. Carrier power means power of the unmodulated carrier signal. So before modulation, we are using one carrier signal. No, the power value of that signal is this one PC. So from this equation, we can calculate the modulation index of the concept. Okay, ma. So we can calculate total power, carrier power, modulation index. Three terms are involved here in this formula. Okay, they will give any two parameters. Out of these three parameters, they will give any two parameters. Then they will ask to calculate the third one. So by using the formula, we can calculate the unknown parameter. That's all. So next, we can solve another problem. Okay, ma. So all of you read this problem. An audio frequency signal. Okay, audio frequency. So we have to note the words, ma. Audio frequency signal 10 sine 2 pi into 500t is used to amplitude modulated a carrier of 50 sine 2 pi into 10 power 5t. Calculate. Some parameters are given. So once again, read this problem. Audio frequency signal. I already said the modulating signals are low frequency signals. Okay, audio frequency signals. The carrier signals are high frequency signals, almost radio frequency signals like that. Okay, ma. So this is our modulating signal, message signal. And the next one is it is used to amplitude modulate a carrier of this one. So this is our carrier signal. First, identify the equation. What are the parameters given? Okay, but two parameters, two equations are completely given. Message signal is completely given and carrier signal is also completely given. From the two equations, what they asked to calculate? Modulation index, sideband frequencies, amplitude of the each sideband, bandwidth requirement, total power. So deliver to the load resistor of 600 ohm. So 5 terms are given. First write the given equation. So they written two equation. Okay, all of you write these two equations first. From the two equations, write the individual parameters. From the first equation, modulating signal equation, the amplitude of the modulating signal is 10. Okay, this is the amplitude value, ma. Okay, ma. So this is equal to 10. Next, from the second equation, the amplitude of the carrier signal is equal to 50. So EC value, carrier signal amplitude is equal to 50. Our first parameter, first question is calculation of modulation index. So the M equal to EM divided by EC. This is our first term. So EM is available here. EC is also available here. Directly substitute those two values. 10 divided by 50 equal to 0.2, that is equal to 20%. Okay, ma, the first parameter is over, calculated. Okay, all of you do the problem, ma. Check your answer here. Okay, ma. So next one is, what is our next question? Sideband frequencies. So frequencies, okay, we have to calculate the sideband frequencies. So I first write the given frequency terms. From the first equation, write omega m term. From the second equation, write omega c term. So omega means a message frequency. This is angular frequency. So from this, write FM frequency. From omega c equation, write FC equation. So write those two frequency terms. Okay, 500 hertz is a one frequency and FC is equal to 10 power 5 hertz or 100 kilohertz. Both are available. Here sideband frequencies. What are the sidebands in amplitude modulated signal? How many sidebands are there? Two sidebands are there. One is upper sideband and one is lower sideband. Upper sideband formula is FC plus FM. Lower sideband formula is FC FM. So already now we have both FM and FC values. Okay, in our hand. So simply directly substitute those two values in this equation. Substitute 100 kilohertz plus 500 hertz. This is the result, 100.5 kilohertz. Next lower sideband is FC minus FM. So this is FC, this is FM, subtract the value. The result is 99.5 kilohertz. All of you check your answer, ma. Okay. Next, third question is amplitude of each sideband frequency. So from the given equation, we can know the amplitude values, ma. So for center frequency, the amplitude is EC. So EC is directly available. This is our EC value is given 50. But for side frequencies, side components, LSB component and USB component, for both the components, we have to calculate the amplitude value. That amplitude value equal to M into EC divided by 2. So the modulation index is already calculated. The EC is directly provided. So calculate the value, ma. That the value is equal to 5 volt. That's all. Next, bandwidth requirement. So after modulation, what is the bandwidth requirement? So the required bandwidth is equal to 2 into FM. So okay, FM is directly provided. Okay, the 2 into FM equal to 1 kilohertz. So after modulation, 1 kilohertz of bandwidth is required. The fifth one, what is our fifth one? Total power delivered to the load resistance of 600 ohm. So see here, this is our total power. The formula is available. The formula is equal to EC square divided by 2R into 1 plus M square divided by 2. EC is provided in the question. R is also 600 ohms is also provided. M in first question we have calculated. So substitute all the values. Finally, you will get this answer. All of you check this answer. 2.125 watts. This is our total power requirement of this amplitude modulated signal. That's all. So in this single problem, we have solved all 5 questions, ma. All 5 different calculations. Modulation index calculation and upper and lower sideband frequencies calculation. Next, the sideband frequencies, sideband amplitudes of calculation, bandwidth requirement calculation, power requirement calculation. So all the calculations are done. So after calculating those values, we can draw this diagram. Okay, ma. So substitute FC value here and FC plus FM value here and write all the values. Here, this is our general diagram. In the general diagram, we have written FC plus FM like that. So, but in problem, just replace this FC by actual FC value and FC plus FM by the actual calculated value and replace all the terms by numerical value. Okay, ma. The calculated numerical value. So in this problem, what we have calculated, so the MAV is 5 volt. So sideband voltage value is 5 volt. EC is 50 volt. Center amplitude value is 50 volt. Sideband frequency is 105, 99.5. Center frequency is 100 kilohertz. So spectrum is simple one. Okay, ma. Shall we move to next problem? Okay, a 400 watt carrier is modulated to a depth of 80%. Okay, ma, a 400 watt carrier is modulated to a depth of 80%. Calculate the total power in the modulated wave. Okay, ma. So 400 watt carrier. So the carrier power is equal to 400 watts. Depth of modulation is modulation index. The another name of modulation index is depth of modulation. 80%. So it is percentage modulation. So divide this term by 100. So you will get the modulation index value as 0.8. So from this equation, total power formula is equal to PC into 1 plus M square divided by 2. PC is directly provided. MC value is also directly provided. Substitute all the values here. Finally, we can calculate the total power. So the total power for the given parameters is equal to 528 watts. Okay, ma. So, for example, in this problem, the carrier power PC and M values are provided. So, instead of that, they can give P total and PC. By giving total power value and carrier power value, they can ask to calculate the modulation index value. Just to do the reverse, that's all. Okay, ma. This is the formula. If you know the formula, you can calculate any parameter. Next, so the power calculation topic is over. Next topic is AM current calculations. So the power is directly proportional to current. So the basic formula is available. Okay, ma. So the power is directly proportional to current. So the power P is equal to I square into R. So the carrier power equal to, this is a general formula. So for here, the total power of AM signal equal to total current of AM. The total power of carrier is proportional to current of carrier. This is the formula. Okay, from the last equation, from this equation, you directly got the equation of total current. Total current is equal to IC into square root of 1 plus M square divided by 2. From this, the modulation index value is equal to square root of 2 into total square current square divided by carrier current square minus 1. This is the formula. Okay, ma. So here also we can solve some problem, ma. Okay, by using these two formulas, they will ask problems. Okay, so we'll solve one problem. The total antenna current of an AM transmitter is 5 amps. If the modulation index is 0.6, calculate the carrier current in antenna. So the total current is provided 5 amps. Ma. The modulation index value is equal to 0.6. So now the total, what is the question? Ma? Carrier current IC. So the formula is available. I total equal to IC into square root of 1 plus m square root by 2. What are the problem parameters given? I total 5 given. M value 0.6 is given. Substitute here, then calculate the IC value. First do it, ma. 0.6 square divided by 2. Then add this result by 1. Then take the square root. Then move this value to left hand side, ma. Divide 5 divided by this answer. You will get the answer. IC is equal to 4.6 amps. Okay, after completing this class, I will share the notes. Okay, you can check all your answers, ma. Next, okay, till now we have discussed about modulation of single waveform. One message signal is available, one carrier signal is available. So the carrier signal is modulated by using single message signal. Okay, up to this is over. So modulation is done there. So because of modulation, the frequency requirement is changed, bandwidth requirement is changed, power requirement is changed. Okay, next one is, for example, if we have more than one signals, what will happen? Is it possible to modulate more than one signals by using single carrier? Yes, we can modulate more than one signals by using single carrier. Okay, so that is called amplitude modulation by multiple sine waves. Instead of single waveform, if we have more than one waveforms, okay, more number of waveforms, all the waveforms can be modulated by using single carrier. Okay, the first one is EM of T. So here we have taken two different signals, two message signals. So a message 1 and a message 2. More signals are available here. So the total signal, okay, at input side, two different signals are available. Two signals are added together. So total signal equal to addition of message 1 and message 2. Okay, these two signals are added together. The added two signals are modulated, okay, are used to modulate the carrier. So the final result is this one. The amplitude modulated signal is equal to, see here, ma, same first component, carrier component, EC sine omega CT, same carrier component without involving any message rated values, message signal rated values. The next one is modulation index of first signal M1 EC by 2 cos omega C minus omega M1. Omega M1 is nothing but the frequency of the first signal minus M1 EC is same, the parameters are same, no problem. Let's look at the frequency components alone. First one is omega C minus omega M1 into T. The second term is omega C plus omega M1T plus. In normal AM waveform, what we have, only we have three terms. But here, along with these three terms, two more terms are added. What are the two more terms? The lower frequency term of the second input message signal. That means the amplitude value, the frequency is omega C minus omega M2T. Okay, ma. Next term is omega C plus omega M2T. So how many terms are here? 5 terms are here. Here two input signals are involved. Okay, ma. Two message signals are involved, but both the signals are modulated by one single carrier. Okay, ma. So in output, what we have? One carrier, two lower sidebands, two upper sidebands. Okay. So one carrier, two lower sidebands, two upper sidebands, and two lower sidebands. Look at the diagram. In the diagram itself, we have 5 spectral components. One is located at frequency omega C. Second one is at omega C plus omega M. Third one is at omega C plus omega M2. Two lower sidebands. One is located at omega C minus omega M. Second one is located at omega C minus omega M2. The amplitude values are there. So the amplitude values of first term depends on the modulation index value of the first signal. The modulation index of the first signal depends on the amplitude of the first signal. Okay, ma'am. For second signal, two sidebands are there. The sideband amplitude values are depending on the modulation index of the second message signal. So the modulation index depends on the amplitude of the second message signal. Okay, Dama. Next, we can calculate one problem. We can solve one problem for this topic. Calculate the total modulation index. Total modulation index. If the carrier wave is amplitude modulated by 3 modulating signals with modulation indexes of 0.6, 0.3 and 0.4 respectively. So this is 2 signals. So we can use 3 signals. So 3 different signals are available. First single modulation index value is 0.6, second single modulation index is 0.3, third single modulation index value is 0.4. So what is the total modulation index value? This is the formula, square root of m1 square plus m2 square plus m3 square. Okay, if we have more input signals, for example, 5 input signals means the modulation index value formula is equal to square root of m1 square plus m2 square plus m3 square plus m4 square plus m5 square. So all the 5 signals modulation index values are included. Okay, Dhamma. So here in this problem, we have been provided only 3 terms. One is 0.6, 0.3 and 0.4. All the parameters are involved here. The total value, MT value, total modulation index value is equal to 0.781. Okay, so this topic is over. Amplitude modulation by multiple sine waves. Okay, ma, is it clear? Okay, ma. Next one is the transmission efficiency of AM signal. So the transmission efficiency formula, the transmission efficiency is equal to upper sideband plus lower sideband divided by total power. What is this? So we are spending some amount of power to transmit the signal from one place to another place. Okay, Dhamma. So the power is the requirement of power. So this much power, the PT is the total amount of power required to transmit the modulated signal from one point to another point. That means from transmitter to receiver side. Okay, out of the total power consumption, total power requirement, how much is actually required? How much is important? Okay, ma. How much is redundant? That means unwanted. Okay, ma. So out of these 3 components, I'll have you look at the diagram. This is the diagram of an AM waveform. This is the center carrier waveform. In this center carrier waveform, no information is available. The message signal is not available. In frequency component also, only omega c is available. Omega m is not present here, not involved here. In amplitude term also, EM is not involved here. So this carrier is completely waste. Okay, ma, this carrier is not having or not containing any message signal, any message information. So that carrier component is not required. Okay, so the power consumed by this carrier component is completely waste. So the efficiency is equal to, see the diagram, the upper sideband and lower sideband are having the message information. Here in M1 we have EM. In M1 we have EM. In omega frequency term also the omega M1 is involved. So in amplitude and frequency, in both the components we have message information. Okay, ma. In frequency component and amplitude component, we have message information. So these 2 components, out of the 3 components, the lower sideband and upper sideband components are required. Okay, this carrier component is redundant. This carrier component is unwanted one. So the efficiency is equal to, out of the total power, the total power is put in denominator. So the out of total power, how much is utilized effectively? Effectively means the components. 2 components are important components. How much power is utilized for those 2 components? LSB component and USB component. So both the components, USB and LSB component. Okay, ma. So the substitute of power value, m square PC by 4 plus m square PC by 4 divided by total power is equal to PC into 1 plus m square divided by 2. Okay, ma. So just to solve this equation, after solving this equation, the efficiency is equal to m square divided by m square plus 2. This is the efficiency formula. So the transmission efficiency depends on what parameter? M2 parameter. That means M square. M square means modulation index. So in the first class itself, in the beginning itself, I informed the modulation index is the important parameter. So the modulation index only decides the degrees of modulation, and the transmission efficiency also calculated depends on the parameter modulation index. So M square divided by M square plus 2. So calculate on parameter value to solve one problem. Okay, a commercial AM station is broadcasting with an unwanted carrier power of, unmodulated carrier power of 10 kilowatts. So the commercial AVM system station is the unmodulated carrier. Unmodulated carrier power means that is equal to PC. PC is equal to 10 kilowatts. The modulation index value is equal to 0.7. Okay, for a sinusoidal message signal. Find the total transmitted power and the efficiency. Total power formula, next efficiency. So we have to calculate the two parameters, total power value and efficiency value. Total power formula is available. Total power equal to carrier power into 1 plus m square divided by 2. Carrier power is directly provided as 10 kilowatts and M is also directly provided as 0.7. Simply substitute those two parameters, calculate the total power requirement. Okay, total power equal to 12.45 kilowatts. Check your answer, ma. Okay, after calculating this one, all of you check your answer. Next, transmission efficiency. Transmission efficiency is equal to m square divided by 2 plus m square. For m value is directly given, it is 0.7. So 0.7 square divided by 2 plus 0.7 square. This transmission efficiency is equal to 0.196, that is equal to 19.6% efficiency. What is the meaning of this? Out of the total power consumed by that signal, only 19.6% of power is consumed in efficient way. That much percent only utilized in efficient way. That is called transmission efficiency. So the remaining, what about the remaining 80%? Nearly 80% of the power is getting wasted because of the unwanted carrier component. Here three components are there. During transmission, all the three components are transmitted, Rama. So out of the three components, one component is not required. So okay, so out of total power efficiency, out of 100%, 80% is occupied by the unwanted component. Only 20% is occupied by the required component. Okay, so the 80% is waste. Efficiency is only 20%. Okay, ma. So okay, what is the solution for this problem? So that's all. The amplitude modulation is over. So we had till now we have seen about amplitude modulation concept, modulation index concept, spectrum diagram, power calculation, current calculation, efficiency calculation, modulation index calculation. All the calculations are over. Okay. At this point, what we are concluding? So in AM, three components are there. So out of three components, two components are required components. One component is unwanted component. So the unwanted component utilizes 80% of the total power. The required components utilizes only 20% of the power. Okay, what is the solution for this? The next topic. The next topic is a double sideband suppressed carrier. What is the meaning of this one? Double sideband. Because from the previous problem, what we have concluded, two sidebands are required components. The centric carrier is not required one. This is unwanted one, redundant one. So we can remove that component from transmission process. So the carrier is suppressed because the carrier is unwanted. The carrier occupies more bandwidth. The carrier consumes more power. So here we are suppressing the carrier. So the carrier signal is suppressed. The required sidebands, two sidebands, upper sideband and lower sidebands, only the sidebands are transmitted. The carrier is suppressed. This concept is called as double sideband suppressed carrier concept. Okay, ma. This is the concept. Already you know very well. So the advantages of double sideband suppressed carrier. So it is more efficient and it has more better signal to noise ratio. Okay, ma. Even though the carrier is suppressed, the bandwidth requirement is same. That is the problem with this one. What is the bandwidth requirement? The frequency range. So the frequency range spacing between FC minus FM to FC plus FM. This spacing or the bandwidth is equal to 2 FM. Again, the bandwidth requirement is twice the frequency of the original signal. So 2 FM is required. So the bandwidth is required. So the power consumption is reduced. The efficiency is improved in that way. In what way? In power way. In power, the efficiency is improved with respect to with the help of this concept. But the bandwidth is same. Bandwidth requirement is same 2 FM. Okay, ma. So we are moving the third topic. What is the third topic? Single sideband modulation. Look at the diagram of this one. This is the power the spectrum of the AM dama. So the unwanted carrier is suppressed. Okay. Look at the sideband diagrams. Two sidebands are there. Upper sideband is FC plus FM. Lower sideband is FC minus FM. Two sidebands are there. See the diagram. These two sidebands are mirror image of each other. Okay, so the transmission of two sidebands means, if you are transmitting two sidebands means, same information is transmitted twice. Okay, the same information is transmitted twice. Once through lower sideband, another one is through upper sideband. So out of these two sidebands, only one sideband is enough. So we can remove any sideband. That is your wish. Based on the application, we can remove any sideband. Here in this diagram, the lower sideband is suppressed because it is suppressed by using dotted line. The upper sideband only transmitted. This concept is called a single sideband modulation. In single sideband modulation, the unwanted carrier is suppressed. Along with this carrier, the redundant sideband is also suppressed. Okay, so the only one sideband is transmitted. So what are the advantages of this single sideband technique? One is carrier is removed and lower sideband is also removed. So the efficiency, the power efficiency is increased. Along with the power efficiency, here the bandwidth requirement is also reduced. Okay, ma. So for DSB, what is the bandwidth requirement, ma? 2 FM. But here for SSB, only 1 FM is enough. Either if you transmit upper sideband, FM is enough. If you transmit lower sideband, for that case also the FM bandwidth is enough. So the the bandwidth requirement is reduced. This is the advantage of single sideband modulation system. Okay, ma. Okay, next in between these two we have one more sideband, that is vestigial sideband. What do you mean by vestigial sideband? In double sideband suppressed carrier signal, two sidebands are completely transmitted. Okay, ma. In single sideband suppressed carrier signal, one sideband is completely suppressed, another sideband is completely transmitted. So between these two cases, we have one more case. What is that? Vestigial sideband concept. Okay, ma. In vestigial sideband, one sideband is completely transmitted, the another sideband is not completely suppressed. Instead of completely suppressing the another sideband, that is unwanted sideband, 1% or one portion is suppressed. The remaining portions are transmitted along with the upper sideband. This is called vestigial sideband. Okay, ma. Okay, is it clear, ma? Next, we will solve some problems, ma. Okay, because we will solve some problems. During the problem, we can understand. The minimum height of antenna required for transmission in terms of lambda is what? Okay, here the problem is, this is 4. Okay, the minimum antenna height is, two answers are available for this one. So lambda by 2 or lambda by 4. You can choose any answer. Okay, the minimum height of antenna required for transmission. Next, in TV transmission, picture signal is dash modulated. Picture signal is vestigial sideband modulated. So here 3 modulated signals are available in amplitude, double sideband, single sideband, vestigial sideband. Out of 3 these modulation methods, which one is suitable for picture transmission, picture signal transmission? Okay, see here explanation. Unlock television systems using vestigial sideband modulation. Okay, Dhamma. Because in VSB, one sideband is fully transmitted, another one is partially removed. Okay, ma. Why? Why we are using vestigial sideband signal in picture in television transmission? Because if we choose SSB, okay, Dhamma. If we choose SSB, one complete sideband is suppressed. One sideband is completely suppressed. What will happen in TV transmission, TV signal transmission? Because in TV signal, we have both the signals, audio and video. Both the picture and the audio, both the signals are available in TV signal transmission. Some important information is available in a single sideband frequency, in lower frequency terms. If we compress the lower frequency terms completely, what will happen? That important information will be lost. Okay, ma, we will miss the important information which is present in lower frequency. So, next, if we use double sideband, what will happen? On the required components and along with the required components, the unwanted components also transmitted. So because of that, the bandwidth requirement is increased. So the bandwidth is occupied by this signal. Okay, the bandwidth efficiency is reduced. So what is available in between these two? Vestigial sideband. Here in vestigial sideband, we can select the frequency. We are not completely transmitting, at the same time we are not completely suppressing. Instead of that, we are doing selective transmission. So up to what is required or up to which frequency is required, that alone is transmitted. The remaining signals are not transmitted. Okay, one signal, one sideband is completely transmitted. The another sideband is not completely transmitted, not completely suppressed. One part is transmitted. This is called vestigial sideband signal. Okay, is it clear? These two problems. Next, third problem. Calculate power in each sideband if power of carrier wave is 176 watts and there is 60% modulation in amplitude modulated signal. Well, if we do this problem. Have you tried this problem? Okay, 60%. So what are the parameters given here? The power of the carrier wave is PC. Carrier wave is 176 watts. PC is available here. Next is 60% modulation. Modulation index is equal to 0.6 is available here. Next, power in sidebands can be calculated by using this formula. Okay, ma. MC square PC divided by 4. This is the sideband power. M value is directly provided. PC value is directly provided. Substitute in the formula, calculate the value. 15.84 watts. This is the answer. 15.84 is answer D. Okay, ma. Next one is, next problem. For 100% modulation, power in each sideband is dash of that of carrier. Okay, 100% modulation. For 100%, four options are available here, 50, 70, 60 and 25. But for 100% modulation, what is the modulation index value? 1. Critical modulation. Okay, Dhamma. The power in sidebands may be calculated as m square into p divided by 4. Okay. So m value is 1. M square is also 1. So m square PC by 4 equal to PC by 4. So the power in each sideband is dash of that of carrier power. So the carrier power is PC divided by 4. So PC divided by 4 equal to 25%. So the 25% of the that of carrier. This is our answer. So the option C is the answer, ma. 25% is answer. Okay. Next problem. For 100% modulation, the total power is what? Four options are available. Same as the power of unmodulated signal, twice as the power of unmodulated signal, 4 times as the power of the unmodulated signal, 1.5 times as the power of unmodulated signal. So see the diagram, the formula is total power equal to carrier power into 1 plus m square by 2. M value is equal to 100%. So substitute the value 1 square by 2. 1 plus 1 square divided by 1 divided by 2. 1 by 2 is equal to 0.5. So 1 plus 0.5 equal to 1.5. So 1.5 into PC. So what times ma? 1.5 times as the power of the unmodulated signal. That's all. Okay, so in today's class, we have covered all the topics of amplitude modulation almost. What is modulation? What is communication system? Next, blocks of communication system. Next, modulation. What is modulation? Different types of modulation. Next, amplitude modulation, concept, mathematical expression, diagrammatic expression, diagrammatic representation of the amplitude modulated signal. Then modulation index. Based on the modulation index value, what are the three classifications of the modulation techniques under overcritical? Okay, ma. Next, power calculation. Next, current calculation of that particular value. Next, two concepts: amplitude modulation, double sideband modulation, single sideband modulation, vestige sideband modulation. Classifications of amplitude modulation is also over. Based on that, nearly we have solved 15 problems. 10 to 15 problems we have solved now. Okay. In next class, we will continue the concept amplitude modulation methods, modulation methods. What all the modulators are available? What all the receivers are available? Okay, ma. Thank you all. We'll meet in next class.